Example, Newton-Raphson method. So let's look together on how to solve Newton-Raphson method step by step. Okay, so I choose example 8, given also in your lecture note. Determine the first roots of fx equal to 8 multiplied with exponent negative x sine x minus 1 by using Newton-Raphson method. Use the initial guesses of x naught equal to 0.3 and perform the computation up to 3 iterations. Okay, use radian mode in your calculation. Okay, why radian mode? Because normally when we use trigonometry, okay, when our function trigonometry, we need to set our calculator in radian mode unless the given starting initial guess is in a degree. Alright, so let's solve this together. Okay, so let me highlight first the important information. So this is our function, and of course this function is continuous. Okay, normally if exponent and also trigo, our function is continuous and also differentiable. And then this is our initial guess. Alright, and then we need to perform in 3 iterations. Okay, so let's look on how we solve this problem. Okay, so first we are given the function fx equal to 8 exponent negative x sine x minus 1. Okay, so remember in the formula of Newton-Raphson method, okay, formula for Newton's methods is xi plus 1 equal to xi minus f xi over f prime xi. So we need the f prime x here. So we need to differentiate this fx. So f prime x. Okay, so remember when you have exponent multiplied with sine, you need to apply product rule. Okay, in order to differentiate, you need to apply product rule. So if you use product rule, so remember product rule. Product rule is u v prime minus v u prime. Okay, you can choose which one as your u, which one as your v, no problem. Let's say I choose this as my u and then I choose this as my v. Okay, by using product rule, okay, saya akan dapat, so u v prime, so u 8 exponent negative x, so integrate, differentiate v, we get cos x. Alright, and then u v prime plus v u prime. Okay, so u v prime plus v u prime, and then I plus, so I keep my v, so sine x, and then I differentiate u, so I should get negative 8 exponent negative x. Alright, and then I differentiate minus 1, differentiate constant, so you get minus 0 lah. Okay, so this is optional. So if I factorize this, okay, if I factorize this, I should get 8 exponent negative x. Alright, and then cos x minus sine x, and then minus 0, no need. So this is my f prime x. Okay, so this is what we need here. Okay, then remember we are given our x naught equal to 0.3. Alright, okay, let's start our first iteration. Alright, so given x naught equal to 0.3 and use radian, your calculation use in radian mode. Okay, so we calculate first f when x equal to 0.3, so substitute into your function. Okay, so I calculate in 4 decimal places, you should get 0.7514, and then for f prime 0.3. Okay, so substitute into your f prime when x equal to your x naught. So here, if you use your calculator, you get 3.9104. Okay, so we start our first roots estimation, okay, by using Newton's Raphson method, or I just use Newton's method. Alright, let's start our first roots estimation using Newton's methods. Okay, so based on the formula, x1 equal to x0 minus f x0 divided with f prime x0. Okay, so we have 0.3 minus f 0.3 divided with f prime 0.3. So we have here 0.3 minus 0.7514 over 3.9104. So you should get 0.1078. Okay, so this is our first root estimation by using Newton method, or x1 equal to 0.1078. Okay, this is the important part. In bracketing methods, at the first iteration, we cannot calculate approximate percent. But in open methods, we already can calculate our approximate percent at the first iteration. Why? Because we already have the previous, means that previous come from your x0. Okay, so in order to calculate approximate percent, means that x1 minus x0 divided by x1 multiply with 100%. Okay, so x1 is 0.1078 minus x0 0.3, and then divide with 0.1078 multiply with 100, and then you put the percentage, so you should get 178.29%. Okay, so this is our first iteration. Alright, so next we move to second iteration. Alright, so in second iteration, we will use this information from x1 0.1078. So we calculate first fx1, so substitute your x with 0.1078 into your function. 8 exponent negative 0.1078 multiply with sign 0.1078, and then minus 1, you should get 0.2272. And then for f prime x1, so f prime when x is 0.1078. Okay, so we have substitute here into your function. Alright, so if you use your calculator, you should get 6.3680. Okay, now we improve our roots estimation. Okay, so the formula is x2 equal to x1 minus f x1 divided with f prime x1. Okay, so we have 0.1078 minus with 0.2272 divided with here we should get negative. Okay, so here is negative, so divide with 6.3680. okay, correction. Okay, this here should be negative value. Okay, so that's why we have negative here. So if you calculate this, you will get your x2 equal to 0.1435. Alright, so now you calculate your approximate percent relative error, x2 minus x1, so 0.1435 0.35 minus x1 minus 0.1078 divided with 0.1435 multiply with 100%. So here you should get 24.86%. So you can see here your approximate percent reduce. Reduce means the value become closer and closer to our roots estimation. Its words converge lead to the true solution. Alright. Okay, we cannot stop here because we require 3 iterations. So let's continue our third iteration. So third iteration, we will use the information from x2, 0.435. Okay. So calculate your f x2, calculate your f when your x equal to 0.1435. So if you use calculator, you substitute here. So you should get negative 0.0089 for your f, and then for f prime x2. So we substitute our x equal to 0.1435. So substitute into your function. Okay, here you should get 5.8682. Okay, so now we improve our root. Calculate x3 equal to x2 minus f x2 divided with f prime x2. So here the value, you substitute back all the calculated value. Alright, so you should get your x3 equal to 0.1450. Okay. Then if you calculate your approximate percent relative error x3 minus x2 divided with x3 times with 100%. So you should get 1.03%. So again, you can see your approximate percent reduced. So it will give you a good sign that our calculation converge toward the true solution. Alright. Okay. So let me minimize this first. Okay, so actually we can summarize, or instead of calculate detail your calculation, you can straight away use the table, no problem. But since this is the first example, so I want to show you step-by-step calculation. So actually if we summarize in table, okay, summarize in table, so this is our solution actually. So number of iteration, okay, and then we put here I, and then here is your xi, here is your fxi, and then f prime xi, and then this is xi plus 1. This is come from Newton formula. Okay, this is your Newton's method formula. And then you calculate your approximate percent in percentage. So the first iteration number 1, so I equal to 0. So here is x0, remember 0.3, and then I substitute all the value that we already calculate into this table. Okay, so this is your first root estimation by using Newton method. Okay, so approximate percent kita dah boleh kira pada iteration yang pertama untuk Newton methods. Okay, dia tak sama macam bracketing. Bracketing kita letak dash. And then iteration yang kedua, I sama dengan 1. So ini X1. Kita juga dah kira 0.1078 ataupun dia datang daripada this value. Okay, kita bawa ke sini. Alright. And then here kita juga dah kira negative 0.2272, 6.3680, and then X2 by using Newton's method 0.1435, and then here 28.86. And then in third iteration, so here, so we calculate X2. X2 kita dapat from previous calculation. And then we just bring here. Alright. So X2 is 0.1435. And then the value here negative 0.0089. 5.8662. And then X3 by using Newton method is 0.1450, and then estimation is 1.03. Then we can conclude that therefore after 3 iterations, okay, the approximated root of fx equal to 0 is come from our last root here. Okay, it's come from our last root here is x3 equal to 0.1450 with our approximate percent is 1.03%. So this is our solution. Alright. Okay, so what we did is actually, okay, saya delete gambar kat sini, saya pindahkan di sini ya. Okay, so this is what we did in this example. Okay, if I plot by using maple, okay, saya plot dengan guna maple. So basically this is the idea. Alright, so ini adalah, this is our function. Okay, and if you plot your function, you will get this curve. Then this is, here is our true solution. Here is our true solution. We aim to estimate this value here, where your function cross your x, means that here we get fx equal to 0. This is our roots yang kita nak calculate. Okay, this is our true solution. And then this is what we did by using Newton's methods. Okay, by using 3 iteration, okay, this is what we did. Alright, the solution that we calculate, we aim, so this is our P3, where P3 very close to our true value here. Okay, so this is what you did by using your calculation in Newton's method. Okay, you have your P0, and then you map here, you get the first slope here. Okay, and then you estimate your first slope. Alright, and then you get another slope. Okay, your first slope give you this. Alright, and then you calculate again until you have this value here. So this is what we did in this example. Alright, thank you.